Good morning, everyone. This is Mark Payne with Frontier Precision here in Anchorage, Alaska. Also have online Allison Walker from Idaho, also with Frontier Precision. And today's topic is going to be talking about mapping with consumer devices. Okay, this is something that has pretty much come about in the last couple of years, and we're seeing this trend is upward. So a lot of people are considering using devices they already have in their arsenal. Okay. Now, there's so many things that come to mind when I think about the use of GPS products and legacy systems. Also GPS products that you're going to be bringing into your arsenal if you've not already have been mapping with GPS. What type of accuracies are you needing to acquire from your GPS, okay? So, we always need to look at the purpose of the data sets, okay? And let the project define those parameters as far as accuracies, okay? Here in Alaska especially, we need to look at the location of the project site, okay? A lot of the new technology that has come about today is cloud-based, okay? Here in Alaska, and I'm sure in Idaho also, there's more so here in Alaska, we don't have a lot of locations that are covered by the cloud. Most everything is done remotely. So we need to take that into consideration as well. The thing is that we need to assess as a user, as a project manager, as a consultant, what that accuracy needs to be. And a lot of times, historically, people go, well, okay, I want, 1 foot, or I want to be guaranteed 1 foot. And that right there is the breaking point between going from mapping to survey. And so we need to be realistic on, I'm having difficulty here. We need to be realistic on the accuracy requirements. It's with recreational grade on down to professional grade. Typically what we're finding out there, plus or minus 10 meters on your low end recreational. You get into your commercial grade products from Trimble to where you can start doing your differential correction. Differential correction is removing the error from the signal. That can be done in real time. Or it can be done in a post-process manner, okay? So we need to be realistic, okay? Where is the project? The access to the project, access to the cloud, if you will, if you're considering using a cloud-based solution. So again, we need to be realistic. Cost of accuracy, okay? So we begin there in the far left-hand corner, right about $2,000, okay? Take or give a few bucks here and there. That will bring you in what we're going to call the professional grade mapping accuracies. Typically, those receivers, those products are going to yield about 2 to 4 meters, okay? And as you can see, as the increase in accuracy goes up, so does the price, and it's a pretty dramatic jump. And this is prior to some technology that was released about 2 years ago from Trimble Navigation. And again, I'm speaking in general about Trimble Navigation parts and products. So what we have here now, if you notice that little red bar there, we've got a sub-meter GPS unit from Trimble called the Trimble R1, coming in right about $2,500, okay? There's some other products also that are sold by Frontier Precision, such as the Geode from Juniper Systems, even come in less than that. But now we have something, it's kind of a, bridging that gap between your low end to your higher end mapping grade receivers. So just some run through on some testing I've done here as far as the accuracy and just I want to dispel any myths about products and accuracy that you may be receiving from different products. Okay, so when we talk about mapping on GIS, mapping GIS on consumer devices, we're talking about smartphones. Okay, tablets are in there as well. Okay, so if you look at taking existing products off the shelf, let's say Motorola Droid, that's what I have, and the testing was done based on my Motorola Droid here, and also we have an iPhone in the office. Compared to known accuracy, okay, survey grade points set in by survey grade receivers here around our building, tied to the National Spatial Reference System, we're looking at plus or minus about 7 meters on these devices, okay? When I say plus or minus, you notice, the next day or the next hour, you could be northeast of the point, come out the next day, and you could be southwest or southeast of the point. So you've got to keep in mind, guys, the plus or minus rule when we're talking any type of receiver, period, whether it's mapping grade or survey grade, or now what we have available to us is the consumer grade product. So keep in mind that plus or minus 7 meters. Now vertical, the vertical was so unrealistic. I didn't even plot it here, but the vertical was not keeper data. Okay, so what we have as far as consumer devices, we have some high-end tablets. Okay, Panasonic with the internal GPS that we have. You're looking at 2 to 4 meters, okay? Trimble also has the tablet, Yuma, also the Key9, right there at 2 to 4 meters, okay? Your lower end tablets, iPad, Surface Pro, you're looking at about the same thing as you're receiving with your smartphone, okay? Typical 5 to 7 meters, plus or minus, okay? One of the things that has been coming back to me here lately is also the ruggedness of these devices, okay? A lot of people want to jump on the Panasonic or Surface Pro platform, and they find out, the iPad or the Surface Pro platform, and they find out after a year of use here in Alaska, which is, the environment's pretty harsh up here, with a lot of rain, a lot of dust, cold and heat, these products are not holding up. So that's one thing you need to make sure that you understand, is that when you're almost and it sounds, well, it's just the fact it is, you're almost at a disposable price range at, the $700 to $900 product range. So let's just look at the Trimble R1, all right? Now that we have this R1, this is available from Trimble Navigation, we have the flexibility to choose your data collection device, okay? That's one of the things we did not have before. Typical, a Geo handheld, that internal GPS engine served as support for the software that was running on that device. Generally, it does have the ability to output NEMA, but that's a whole different issue in itself. Bluetooth connection, pretty standard today. It's fairly reliable. I've not had any problems with it. It is a sub-meter GNSS receiver. So, and in this case, this is going to be the Navstar or the GPS, which is the U.S. satellites, and the Russian satellites, or GLONASS, okay? So typically on any given day with those two constellations, you're looking at anywhere from 15 to 18 satellites all at one time in view by your receiver, okay? Oops, excuse me. Correction sources, SBAS or WAS, it's a satellite-based system that's available, and I'm just going to talk North America, available to us in North America. It is a stationary satellite that is on over the equator. Depending on your latitude, will depend on the elevation to that satellite. Lower 48 footprint, as far as using WAS, is great. Up here in Alaska, that satellite is either PNR 135 or 138. I forget which one. That satellite here in Anchorage is about 15 degrees on the horizon to the south. So you get into an east-west canyon type environment, you lose that ability to receive SBAS corrections. You can also perform differential correction in Pathfinder Office, like a lot of you are used to, using the Trimble R1 connected to different devices. Okay, same thing with tablets. Surface Pro, iPad, you know, Juniper's got a new product called the Cedar. It's Android or most any Windows tablet. Right now I am running Windows 8, I'm running Windows 10 on various hardware platforms, all working flawlessly with the Trimble R1. And here's one thing that we haven't thought about, or maybe you have, and I'm just now thinking about it, but kind of thinking outside the box here is the current hardware and legacy hardware that Trimble has out there on the market. So let's just take your Juno 3, okay? A lot of you guys may own those. Those are, what, 2 to 4 meters at best. You can take that Juno 3 using your TerraSync or using your ArcPad and interface to the Trimble R1, and now your Juno 3 serves as solely a data collection platform, and your receiver, the R1, will be your GNSS receiver. And you know, you've taken a device that is 2 to 4 meters at best, and now you have a sub-meter device. So any of these products here, GeoExplore, XT, Juno, Nomad, the Juno 5, Yuma 2, all of those products I've tested with the R1, you know, it's pretty much plug and play. So if you've got some old products sitting in the bottom left-hand corner of your desk, you know, hey, you know, this may be a product that you could justify getting them out, dusting it off, and coupling that with a Trimble R1, and now you have a sub-meter unit using those devices as data collector. So just picture 1,000 words, okay? So all of these devices, okay, I have tested with the Trimble R1. They all work just fine. Now, you know, we're a big fan of TerraSync. It is a Trimble product. It is something that I send out mostly to my customers. Of course, you know, we got a fair share of ArcPad users as well. A new product that came out from Juniper. We acquired this product when we acquired EDS, that is Frontier Precision purchased EDS, and they were a Juniper system dealer. And one of the products they have out now is the Geode. And I have tested this little device, and it works. It's literally plug and play. Been very impressed with this device. So it gives you, again, the flexibility to choose your own data collection device, Bluetooth communication, sub-meter GNSS receiver, GPS and GLONASS, and you have your different correction sources, okay? Such as SBAS. So you take the Juniper Systems Geode, and you can couple it with any of these products here, okay? So in my arsenal, I have each one of those. I have communicated or hooked up the Geode to these devices running ArcPad, and again, it's pretty much plug and play. And it gets you below, below that $2,000 range for a receiver. So let's just kind of walk through taking a device and connecting it to a device as far as hardware, and then starting at the software of your choice. Just a quick run through on how it's done. Here on my computer, I do have Bluetooth on my computer, which is nice. So basically, you go into your Bluetooth configuration software on your device, and you will turn Bluetooth on. Your data collector will discover that. You will then pair with it, and then you will assign your communication port. Okay, it will be an outgoing port, and it will give your port numbers. Different softwares kind of handles this differently. ArcPad versus TerraSync. If you have any problems, just give me a call or the sales rep in your area, and we can step you through it. But basically, we start up our Bluetooth device. We discover the R1 or the Geode. We assign a COM port to that device, and away we go. Okay, up and running here. The screenshot here. I'm showing it in TerraSync. If you look at the estimated user accuracy right here, we've gone from a product that would normally be 2 to 4 meters, we're now looking at 53 centimeters using the R1. And those are pretty reliable numbers, okay? The other thing that's great about the R1 and using it with your legacy devices is that you can also perform differential correction or post-process with the Trimble R1. If you're using TerraSync, it's straight up. It produces an SSF file. You take that SSF file, run it through Pathfinder Office differential correction, and pretty much, you step through the wizard, and it will process it. Here, you're seeing an estimated accuracy for all the positions falling at 100%, 30 to 50 centimeters. So let's look at the software rundown software rundown on your different platforms, okay, and who is supporting what. Now, Allison is recording this. This will be available to you later on. Allison, when is that going to be available to download?
Should be up by the end of the week.
Okay, so end of the week. All right, great. Okay, Esri software. Working with the Juniper Systems Geode GNSS receiver, okay? It works with collector. It works with a survey 123, and it works with ArcPad. Would not run on that platform. That hardware platform is the Juniper system. It would not support Trimble positions, okay? TerraSync, Esri software, working with the Trimble R1, very flexible. Esri collector, survey 123. ArcPad, either real-time or post-process, so you can always use Trimble positions if you want to do post-processing with that device. TerraSync, and also TerraFlex. Is there anything that you wanted to add here, Allison, that I've not covered?
Nope, I think you've got it covered there. That is the proper list for that receiver.
Okay. All right. Anything else you would like to add in general?
Well, I guess I would just note that in Collector, ArcPad, TerraSync, and TerraFlex, it is easy to choose which receiver you're using. On Survey 123, it doesn't quite have that functionality fully supported yet, though that may change in the very near future. In fact, there might be an update happening right now as we speak that will change that. But for Survey 123, you have to configure it on the device first and make sure that you're using another app. For example, on Android, you have to use the Bluetooth GPS app to ensure that that position is being used in your software, just because Survey 123 isn't quite smart enough yet for you to choose which receiver and which COM port you're using. So that would be the only caveat, is that that one's just a tad bit more difficult. But otherwise, I think everything else is great there.
Okay. One of the things, gentlemen, is that if you go down this road with the Geode or the R1, just work with your sales rep. They've already done this, got the T-shirt. Understanding the COM ports is can be kind of frustrating, but once you do it from scratch, you see what is being produced as far as available COM ports for your software device or for your software, and once you got that sorted out, it's pretty simple after that. So, well, I guess that concludes our seminar on the bring your own device. Are there any questions right now?
It looks like you do have a couple of questions here. One question is, how about the costs for the receivers?
The Geode, the one I would purchase, of course, you know, I would purchase the Geode with nothing but GNSS capabilities. So you're looking at right at $1,900. The Trimble R1 is $2,495, so you know, just shy of $2,500.
Okay, and there's another question here I can answer for you. What software options exist for using an R1 with iOS device? Of those listed, which ones actually run on iOS? So the three softwares that were listed there, the Trimble TerraFlex, Esri's Collector, and the Survey 123 apps. Those ones will all work on iOS. TerraSync and ArcPad do not run on iOS or Android.
Okay. And you know, the other thing too, you know, we normally have a demo pool of equipment that we can send out to your site so you can take and evaluate the hardware, you know, hands-on, so to speak. So that's something else that you can work with your sales rep with in getting your hands on these devices. I can tell you this now, and this is my personal experience, is that I know last year I was getting a lot of feedback that different divisions, departments, whatever, agencies up here in Alaska were going with the iPad. This year, it's been about 1 year since I, you know, heard that news. They're taking a look at something a little more rugged now because they're just not holding up in the field. And one of the products that they're looking at, and it is the Mesa 2. There, your top left of your screen there. Rock solid product. They now have that out not only in Windows 10, but they have it out also in an Android model. Okay, so
here's
any
another
more questions?
Yeah, here's another one for you, Mark. What with an older Trimble model, somebody's asking which is better, an external antenna or an R1?
Well, it would depend on the model. If you got a receiver that's spec'd out to what, you know, 1 to 2 meters or 2 to 4 meters, you know, that's as good as it's going to get. If you're running a Geo XH, definitely, you know, you could go with the external antenna. That would certainly improve things quite a bit. But what I would probably look at is, like, you know, because you're going to spend $1,500 to $1,600 for an external antenna, whereas you could buy the Geode or the R1 for anywhere from $1,900 to $2,500. If you go that route, and so now you've got a data collector / GPS unit, and now you have an external GPS unit. I would probably go that route because at some point you might want to break these two apart. Maybe buy another low-end data collector, use it with your R1, and you still have that that GPS receiver you had prior to your purchase that will still go to the field and perform at that 2 to 4 meter level. Does that make sense?
Yeah, that's a good answer.
Anything else?
Somebody had asked about costs for the RTX correction service. I don't have those handy, but maybe you know those off the top of your head?
I do not, but how do we get back with them?
We can figure that out. I've got his name and question here, so we can reach out to you after the webinar.
Okay. Yeah, we'll get back with you after the webinar here. So, all right. Well, I sure appreciate everyone attending. Hopefully, we all learned something today about what's out there as far as new products and how to rejuvenate our older products. And that the difference between what you're paying for the store-bought, we'll call it, tablet versus a ruggedized tablet, it's really worth that additional $1 to put in that ruggedized tablet, because it's just, here in Alaska especially, we do have a lot of problems with contamination from the elements inside receivers and data collectors and robotics, whatever. We see that a lot just because of the harsh environment up here. So, all right. Well, Allison, I appreciate you setting us up and getting us through it. And if there's no more questions, we'll go ahead and end.
Yep, I don't see any more for now. And for those of you who had other questions that we need to get back to, we'll take care of that later.
All right. Okay. Let me get down the bottom slide here, and there we go. There's your contact information for these different offices here. And Allison, I guess we can just pull the plug here in about a minute.